Okay, so last class we talked about standard form, and our equation for standard form is?
AX plus BY.
Good, Trey. AX plus BY equals C. I wrote it in massive letters up here for you, so you can remember this. AX plus BY equals C. Miss Charlotte, do you have the pen that was here? Maybe? I'll improvise until then.
Yeah, steal a pen from the other one.
Okay, so again, standard form is AX plus DY equals C. Thanks. I did all of that. Alright, so what we have to do for each of these is get it into an equation and then change it into that standard form. Remember, standard form, there are no fractions, no decimals, and what else has to be true? What else is true for standard form? Yep, x and y have to be on the same side, and there's one more thing. Right! The value in front of x, our coefficient here, cannot be negative, so this has to be positive. Okay, so for numbers 2 and 3, they gave us an equation. We just have to get it into standard form. But number 1, they didn't even give us an equation. This was like some of the problems on your homework last night. They didn't even give us an equation for number 1. So we need to first write an equation with information we already know, and then we can change that into standard form. So what other kind of equation do I know other than standard form? What's my other one? Very good. So our other equation that we have is called slope-intercept form. Y equals mx plus b. Gives us our slope and our y-intercept. So we need to write this information into an equation here and then change this into standard form. Okay, so we need slope and we need b. They gave us 2 points, so let's find our slope. y2 minus y1, so -4 minus a -3 over x2 minus x1, -1 minus 2. So minus and negative becomes plus positive. -4 plus 3 gives me -1. -1 minus 2 gives me -3. Good. And -1 divided by -3 is just 1/3. Alright, so here's my m value.
You're crazy.
Okay, so now that we have slope, we need to find our b value. This is what we were doing for those 3 days before we even learned standard form. Okay, so I've got my slope. Now I need to find my b value. So I write out my equation, y equals mx plus b. And let's fill in the values that I do have. So I have my slope is 1/3. And then I have x and y. I just pick one of my points. I'm going to go with the first one here. X is 2, y is 3. So I'm going to replace my y. Y is -3. And replace my x. X is 2. So all I've done is taken my values I have and put it into my equation. Now I can solve for b. So I get -3 equals 2/3 plus b. If you need to use calculator to help out your fractions, that's fine, do so. Subtract 2/3 from both sides. And I get b is -11/3. Is that what you guys have? And make it -11/3. -3 minus 2/3.
-3 minus 2.
And remember, you have to put your fractions in parentheses. Minus parentheses 2/3. Yeah, so minus
2/3. 2, 3. I got this. Okay, -3.
So change it to a fraction. Abdul?
not working.
Not working. Math fractions. So we have -3 minus parentheses 2/3. Yeah, Trey, we got the same thing. Math. Fraction.
Mine's like, it's stuck. Okay, now it works.
Okay. -11/3. Good. Alright, so if you do that in your head like I did, go ahead. You don't have to use your calculator, but use your calculator, double check. Alright, so now that I have my b value, I can write out my equation.
What do you
Alright, so Tayshawn, help me out here. What is my equation?
Huh?
What is my equation? I found my slope and I found my b value. What's my equation? Start it off with y equals.
Y equals mx
But what's my m?
1/3.
Good. 1/3x plus what? What's my b?
Plus -11.
Good. -11/3. So -11/3. All right. Here's my equation. So finally, we have an equation. We used what information we learned the first half of this unit. We used the information we learned the first half of this unit to write an equation. Now we can move this to standard form. All right, Joe, what do you think we should do first to get this into standard
got
form?
this. Is it 1/3 x plus? Yeah.
I did.
What do you want to do?
Subtract 1/3.
Good. We need to move our x to the other side, right? We're still trying to get ax
Oh, yeah.
plus by
Rewrite the equation.
equals c. So I need to subtract my 1/3 x. So I have -1/3 x plus y equals -11/3. All right, we've got it in this format, but I can't have fractions. And I can't have that first number be negative. Because in standard form, you can't have fractions, and you can't have your first number be negative. All right, so how do I get rid of those denominators? Very good, Naman. We multiply by what are my denominators? I have a denominator of 3, so I'm going to multiply by 3. And I like what Naman said. He said not just 3, but let's multiply by -3. That'll get rid of my negative as well. You could do that in 2 different steps, but let's do it in 1. Alright, now we distribute this to both pieces. -3 times -1/3 x is just x. -3 times 1 is -3y. And -11/3 times -3 is positive 11. So I have no fractions, no decimals, and my leading coefficient is positive, so we're good. This is yes. Alright, so again, we had to first write our equation, then we can move it around to get standard form. So find your slope, plug in your slope, and x and y to find your b, write your equation, and then we can move that for standard. Alright, questions on that one?
No.
Good? Alright, so then our next ones, 2 and 3, they don't require as much work. It's already in an equation for us. All we have to do is get it in standard form. Again, ax plus by equals c.
What?
Okay, I'm going to clear this out some so I have more room. Okay, I have decimals. I can't have decimals. Who remembers what we can do to get rid of those? Multiply by what?
Turn to 7, but just how many places over it is.
Right, so we could turn this into a fraction, but Miss Charlotte taught us a quicker way to do that. Look at how many decimal places, or how many places you have after the decimal. Here we have one after the decimal, right?
And then add a 0 to it, that makes it 10.
So this is in the 10th place, so we want to multiply by 10 then.
But I would move it. Sorry.
You could move it first. You can move it first. So I'm going to multiply by 10 on both sides. Good job, Nami. All right, Q1, what do I have to do with that?
You got to distribute.
Good. All right, and your calculator multiply 10 times 0.5. What do we get?
find it. Wait, I can't have it. I don't have it. I got 5.
I'm about to get
Oh, you need to transfer a
I
calculator?
got 5.
5, good.
No.
5x, and what's negative 3 times 10?
Negative 3 times 10. 10. I can make it 3.
Nope, 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 nope.
10. Negative 3
She's not dead body. Oh, yeah.
Alright, minus 30.
Negative.
What do you mean?
Alright, and Trey, what did you say we have to do?
Oh.
What did you want to do first? Good, we need to move our x over. So, we have a couple of options. If we subtract 5x over, it becomes negative, right? And then we have to divide by -1, like we did for this first one here. We subtracted x over, that became negative, and then we had to get rid of that negative. Or, I'll show you another way. Instead of subtracting the 5x over, let's leave that positive. Joe and Edward.
How do we do 10x? Oh, yeah.
Instead of doing that over, let's leave 5x positive
Leave them alone.
and subtract my 10y over. So then I get 0 equals 5x minus 30 minus 10y. And then let's add our 30 over. You could actually do it on the same step if you wanted to. So we get 30 equals 5x minus 10y.
Wait, can you go up?
So again,
That's what it
instead
is.
of moving my 5x over, instead of subtracting that because that becomes negative, what I did instead was I just subtracted my 10y over and then added my 30 over. That meant that my 5 stayed positive. You can subtract 5x over and divide by -1. That's perfectly fine. You can do either way.
Either
don't
way,
need to
you're gonna have the same number of steps, it's just a different type of steps.
Okay. Yeah, just do the first way. You can do it the first way where you subtract it over and divide by -1. That's perfectly fine. Some people don't like the I heart division with the negative.
I love
Okay, and then my last step, I need it where the 5x and 10y are on the left side, so I can flip my entire equation around. 5x minus 10y equals 30.
Water cycle. Same thing.
Okay, questions on that one?
No.
Alright, so finally our last one. We have 2 fractions here. Now, we taught you a couple of ways to do this one. And I think what might just be easier is what I'm going to tell you now. So, if what we did last class makes sense, that's fine. But I'm going to show you another way that might be a little bit easier to remember. It's one way that will work for everything. So we have 2 different denominators here. We have a 2 and we have a 3. We need to get rid of both of them. So eventually we'll multiply by both 2 and the 3 to get rid of both of them. Now, what you want to do is, because sometimes if you multiply by one of your denominators, it gets rid of more than just one. So what we're going to do is pick your largest denominator. So here in my equation, what's my
3.
largest denominator? Good. 3 is my largest denominator. So to get rid of it, I'm going to multiply both sides by 3. So I have 3y equals, go ahead and use your calculator to help you out with this one here. Remember, fractions have to go in parentheses. So I have parentheses, -5 halves, close parentheses, times 3. Change that to a fraction.
Please remember that you have to keep putting fractions on at the start of the fraction.
I remember.
So we get -15 halves. X, and 7/3 times 3 ends up being just 7. So notice we got rid of one of our fractions. So multiply by your largest denominator first. Okay, Now we still have another fraction to get rid of. So what should I multiply by now? 2. To get rid of this fraction, we need to multiply by 2. That's now my leftover denominator, my largest one that's left. So now multiply both sides by 2. Alright, so 2 times 3y is 6y. And again, we have to distribute this just like up above. We have to distribute our 3. So when we multiply 2 times negative 15 halves, what do we get? Negative 30 divided by 2, which is negative 15. Yes. And then 7 times 2 is?
7 times 2 is
14. There. So multiply by your largest denominator, and keep doing that until you get rid of all your denominators. Now we have no more fractions. Now we can move stuff around. Oh, and how nice! When we move our x, it's going to be positive. All right, Q1, what do we want to do?
What do we want to do? You gotta add 15.
Good. Add 15 x to both sides. And Q1, can I add 6y and 15x together?
No.
No, why not?
Because it's not like terms.
They're not like terms. Very good. All right, so x comes first. These cancel out. You have 14.
It started from a certain time.
And that's our final answer. The first one's positive, and there are no fractions or decimals. Yes, no. Yes, very good. So what Navin said is, in the beginning, we could have multiplied by 6, because look at what we did. We multiplied by 3, and then we multiplied by 2. That's the same thing as just multiplying by 6. Both of our denominators, 2 times 3 is 6. So you could have multiplied by 6 in the beginning and gotten up there. Good. Very good. Okay, so again, just recapping here. If they don't give you an equation, you need to find your m value, find your b value, and create an equation to move it into standard form. If they give you an equation, get rid of all decimals, get rid of all fractions, and move it so that x is positive in front. To get rid of our decimals, just look at how many places you have after the decimal. Here we were 1 place afterwards. That's the tenths place, so we multiply by 10. If it was 2 decimal places afterwards, let's say, for example, we had, let's say I had 0.15x plus 2.3y equals 7. Here I have 2 decimal places afterwards. Here's only 1, and that's none. So I need to multiply by 100, because this is the hundredths place. So I would multiply by 100 on both sides. Alright, so look at how many decimal places afterwards. That tells you how many zeros afterwards. Multiply by 10, or 100, or 1,000, whatever it's. Alright, questions on that? Yep, we're going to go to homework. So today we're going to be doing some more with word problems. Everyone's favorite. We've already done half of these before, ones that are like half of these before, where we had to write equations in slope-intercept form. But today we're going to also look at some where you have to write the equation in standard form. So you'll see our notes up here at the top. It says look for the rates. If you have only one rate, then it's going to be in slope-intercept form, which is y equals mx plus b. So for example, say you're going to the movies and you say a movie ticket is $8 per ticket. That is one rate. $8 per ticket. Yeah.
15.
It's ridiculous these days. Although on Tuesdays, sometimes they have a half price.
What are you talking about?
At Reston, it's half price on Tuesdays.
What? And at Worldgate, Wednesdays,
Yeah.
one day is Keep Discovery, one day is,
Show my amazing.
And you guys aren't seniors.
I got my student ID.
Okay.
But
And when we have 2 rates,
please now.
when we have 2 rates, that's standard form. So remember, standard form is ax plus by equals c. So 2 rates, maybe it's maybe you go to the movies and you get popcorn. So $8 movie ticket, and $5 per popcorn. So that's 2 rates there. 2 per statement. It's 2 things that have an amount associated with it. Alright, so let's go and just dive into our problems here. Number 1. It says a phone company charges a basic fee of 60 cents plus 15 cents per minute. Write an equation that models the cost of the call, y, in terms of x, which is minutes. Alright, what does this word per mean? Do you guys remember this from before? Multiply. Very good, Ivania. So we are multiplying whenever we see the word per. It goes last name first and first. That's common. Okay, so per means we're going to be multiplying here. And they told us that y is the cost of the call, and x is the number of minutes. So when it says per minute, minute is x, and we're multiplying. So we have 15 cents per minute, so 0.15 times x. It's just like we did back when we first did word problems. So we should all be writing this down, underline the same stuff. Notes. Okay, a basic fee of 60 cents. So that's just an initial amount. We don't have to keep paying that every single time for each minute. We have to pay 15 cents for each minute, but we also have just a flat rate of 60 cents. So our total cost of the call, so the total cost, y, is going to be that initial amount, 60 cents, plus for each minute we have to pay 15 cents. So plus 0.15 times x. Now let's rewrite this in the proper format. It's y equals mx plus b, so we should have our x first. Y equals 0.15x plus 0.6. And that's our equation.
That's wrong.
So again, it's the initial amount of 60 cents. And then for each minute, we have to pay 15 cents. 0.15 times x. We will put our dollar sign when we write the actual answer.
How much for 45 minutes?
Yeah. So how much would a 45-minute phone conversation cost?
Oh.
Alright, so they gave us a number here. 45. Does 45 represent x or y? X. It says 45 minutes. Minutes
Did we just
are
plug that
x.
in like 0.15 times 45?
Yeah. So we're putting in 45 for x. So y equals 0.15. Instead of x, we know it says 45 minutes plus 0.6.
And then once we get our answer for
So let's go and find out what our answer is. Put this into your calculator.
$7. $6.70.
Let's double check that.
Times what?
0.15 times 45 plus 0.6.
0.15. 0.15 times.
Yes. 0.15 times 45 plus
Plus
0.6.
$7.
Good. $7.35. And we always label our answers here. So as Joe was saying earlier, that's $7.35. Alright, so $7.35 is the total amount it's going to cost.
Two questions.
Okay, questions on that first one? Alright, so this is just like we have done in previous classes. Now, let's take a look at number 2, where we have 2 different rates. Yes?
Why do you always have to switch?
Because we want to write it in the proper format. For one rate, it's y equals mx plus b, so x comes first.
How do you know which one is x?
It says x.
Because
They told us it's 15 cents per minute, and they said minutes are x. Okay, so let's take a look at number 2. Number 2 says Ellen has $15 to spend on cat food and dog food. We should be reading along with me. The cat food is 50 cents for each can. and the dog food is $1.50 for each bag. Write an equation describing the situation. Alright, so it says that we have cat food and we have dog food. And cat food is 50 cents for each can. You can think of that also as per can for each can. And the dog food is $1.50 for each bag. So what are we going to have to do with those? Right, we're going to multiply those. So cat food is 50 cents for each can. Now, they didn't give us what variables to use. Alright, so let's go ahead and assign it. Let's make our cat food X and our dog food Y. So my cat food is 50 cents per can. So I know my cat food is 50 cents per can, and cat food is X. And my dog food is $1.50 for each bag. And dog food we said was Y. And how much total money does she have to spend? 15, right. So the total amount she has to spend is $15. Alright, so again, the total amount she has is $15, and she's purchasing two things, cat food, dog. Each one has its own price. So we have two rates, thus we're using standard form.
Oh, shit, you keep the balance.
And we have an AX plus BY equals C. Alright, questions so far?
Oh.
Okay, so this is our equation here. Alright, yes. You want it to be in standard form, so your constant, whatever doesn't have a variable with it, is on the right side. How badly did you mess up that board?
Governor's school game. Highway.
Okay,
We finished reading the
so
government
letter
statement.
A. How many cans of cat food can Ellen afford if she buys 5 bags of dog food? Alright, which variable represents cat food?
X.
Good. And which one represents dog food?
Y.
And do we know how much cat food? It doesn't. We don't know, right? We're trying to find that out. And how much dog food does it have? Right.
Wow, that was
Killed it that time.
It's key one.
obvious, dude.
It's key one touching like
So
that.
guys, this is why we should not.
Okay, so how many bags of dog food does she have?
5.
5. Right. So they told us 5 bags of dog food. So I know that Y is 5. Okay. So what do you think I'm going to do with that?
I mean, back to dog food.
Yeah, put it in our equation, right? We don't know X. We're trying to find that. And Y was 5. So now we just have to solve for X. Alright, so you're definitely going to want to be using your calculators to help you out with all these decimals we have going on. What's 1.5 times 5? Good, 7.5. And Q1, what do I have to do next?
You got to
Oh, multiply by 10 more.
See that.
multiply by 4.
We could multiply by 10, but we're just solving for X here. If we needed it to stay in standard form, perfect standard form, then we subtract what?
I 0.5.
But we don't need it to stay in
7.5.
7.5. It didn't say write the equation in standard form. It just says that we're solving. We're trying to find how many X. So if it said write the equation in standard form, definitely get rid of those decimals. But here we're just solving. Alright, so yes, subtract 7.5. Can I combine 15 and 7.5? Can I combine 15 and negative 7.5?
Sure. No.
Yes! They're like terms. Do they have any variables with them?
Oh no.
What's 15 minus 7.5? 7.5! They don't have variables with them, they're like terms. You guys are so scared of just adding and subtracting numbers together.
Yes.
Okay, now what's my last step?
It's like, dude, the guy behind you.
Divide. Right, now we can divide. Alright. Whoa, there should not be an X there.
Fox, why are you giving us this little space?
Okay. So then we get X equals what? and 15. And 15 what? What are we talking about here? 15 what?
Cat food.
15 cat food?
Cat.
15 cans of cat food.
Okay.
And you must label that. We will take off points for you not labeling what you're talking about there.
15 what? Tim Sean, that's like you.
Alright, Keelan, help me out with the next one. Actually, before we move on, any questions on this? Alright, Keelan, you're going to help me out with number 3. So it says Tom's truck can hold a total weight of 500 pounds. If each bundle of wood weighs 100 pounds,
Yes, add them together.
and each sack of sand weighs 50 pounds, write an equation that models the situation. This is perfect for wintertime. If you ever get stuck in the snow or ice, you can use sand to help you out. Put it underneath your wheels.
So you put.
So like in Ohio, we often will have sand, like some sand
Ohio.
in our cars, so that if you get stuck, you can just put some underneath the wheel and help you get out.
We do it with sand. We often use cat sand.
Yeah, I use
Cat sand.
Especially if you have a cat.
rock salt. Yeah,
Rock salt is very good because then you can use it.
rock salt is also necessary for making ice. Okay.
So you put y.
We're giving you valuable life.
Y equals 500.
Okay, so let's take a look at how many rates we have. It says each bundle of wood weighs 100 pounds. We see a key word there. Each bundle. What am I going to have to do? Multiply. So each bundle of wood weighs 100 pounds. What else do we have? Not just wood, but what else, Joe? Good, we also have sand. Now please leave them alone.
I did.
So we also have sacks of sand, and it says each one. So again, we're gonna have to multiply here.
Oh.
Now, we've been using x and y because those are the two variables we use for standard form. But I like to use variables that represent what we're talking about here. So we're talking about wood. Are you guys alright with using W?
Yes.
And yeah, you can definitely still use x and y. And for sand, about S.
Oh, you.
Alright, so you can use different variables. It's just an unknown value too.
It's not my phone. Is it my
This is
phone?
water bottle.
Yeah,
Let's take the notes.
I already did it.
You didn't write a W notes yet?
Oh yeah, I did actually.
I wanted to.
I was ahead of the game.
Oh, good job.
W.
No, that's what I thought. Okay, write an equation that models the situation. So each bundle of wood, we have to multiply with that. How much does each wood weigh?
100.
Okay, so we have 100 W. 100 for each wood.
That's what I said already.
Each wood. Each bundle of wood. Oh, I'm like you. Okay, and what about our sand? What's the next part gonna be?
Stop.
Yeah.
I don't know what is wrong with you guys that you can't see light and stay quiet during class. It is inappropriate.
All right, Ivania, what's the next chunk gonna be? Very good. 50S for sand. Again, you can still use X and Y. And what's the total weight the truck can hold? 500. So again, if you used X and Y, you could have said 100X plus 50Y equals 500. Alright, so here's our equation. Now it says how many bags of sand can he load in the truck if he loads 3 bundles of wood? What information did they give us?
Just the truck can hold how much each weighs.
We know how much each weighs, but what does question A give us?
Question 8.
Oh.
Yeah, how many bundles of
3
wood?
bundles of wood.
Good, so if we have 3 bundles of wood, what's its W equal?
300.
How many bundles of wood do we have? 3. So W is 3, but that will be
300 things.
Okay, so let's put this in our equation. We're trying to find the bags of sand, so we don't know what S equals. So 100 times, instead of W, we have 3,
Oh, okay.
plus 50 times S equals 500.
500.
Yeah,
Alright, Q1, what's our next step?
Yeah, call them out. Alright, you got a 300.
What are we gonna do? Good, subtracted 300.
Good job, man. 7.
And what does that give me on my right side of the equation?
200 things.
Good. Alright, yeah, that's a 50.
What?
Say, Sean, what's my next step? I need to solve for S. I need to find how many bags of sand.
That's the goal.
Help him out, Abdul.
What are we doing? Are we on the
Divide.
Divide! We're multiplying 50 times S, so to get S by itself, divide by 50.
Okay. What's your best part?
Alright, 200. Yes, actually, last class, you guys did the best out of all of our classes. Let it be known that last class, 3rd period, did the best out of all of our classes. But they got through everything. They got through everything.
Did we ever do better than first period?
Last class, you did better than first period.
Let's fight first period now.
Okay, 200 divided by 50 gives us 4. 4 what? Bags of
That goes sand.
bags of sand.
4 sand.
Okay, questions on that one? Let's flip it over to the back side.
What's you didn't help pick it.
You don't need to get it back. Ours is on the
Oh,
front.
sorry. Edgar's on the front. Stick to the front. Edgar.
Edgar wants to buy some roses.
Oh, Edgar wants to buy some roses for his girlfriend. The roses are $1.75 each, and the base is $3.25. Write a linear equation to model the situation.
Linear.
Alright, let's break this down again. The roses are $1.75 each. What does that word each mean we're going to have to do?
Per.
Multiply. Alright, roses.
Roses.
We'll go back to using X and Y, or do you guys want to use R?
C.
Let's do X and Y. Okay, so we'll leave roses as X. And it says the base is $3.25. Is he going to have to buy a vase for every single rose? No, he just buys one vase and then puts all the roses in that, right? So the total amount he's going to buy, or the total amount he has, the total amount it's going to cost, we don't know that. And it says each rose is $1.75. So $1.75 for each rose. Again, each multiplying there. X represents our roses, and then we have to pay the flat fee of $3.25 for our base. So $3.25 plus however many roses we bought times 175 will give us the total amount here. So Y equals 1.75x plus 3.25. Guys.
So what you have to do is.
Alright, so we need to make sure we use our variables. Say which one they are. X is the number of roses. Gentlemen.
That's cute.
You do 20
I don't
minus
suck that bad.
3.25 and then divide the answer.
And Y represents the cost. Okay, now for letter A. It says, how many flowers can Edgar afford if he has $20? Alright, Joe, what do we do?
Times 3.25.
Wait, sure.
Hold on a second. So he has a total amount of $20. Now we need to solve for x to see how many rows it's. So what do we have to do?
Minus 3.25. And
Subtract
then
it.
divide the answer by 1.75.
Good. And what does 20 minus 3.25 give us?
I could care less.
Good, 16.75. And as Joe said, we need to then divide by 1.75. Q1, are you writing this down? You should be writing this down, Q1. Okay, Sean, you should also be writing this down. Alright, what do we get when we do 16.75 divided by 1.5?
11.
11?
Hold on.
One 1.75.
Oh,
10.
No?
Yes.
9.57.
Good, 9.57. Okay, now it says how many flowers can Edgar afford? Can we buy 0.57 of a rose?
Yeah.
You should have cut a petal and
No, we don't buy 0.7. We don't buy 0.57 of the rose. So how many can he afford? Only 9. He doesn't have enough money for 10.
Well, he has
He can
2 flowers.
only get 9. Well, they didn't tell us, so we don't know. So he can only afford 9 roses. So make sure you're reading the problem to take in consideration the context. It's not just 9.75. It says how many flowers can he afford? He can't afford the 10th flower, so he can only afford it. All right, questions on that? Okay, flip it over. Trey's family is having a barbecue,
like
No.
and Trey's mom sent him to the store to buy the chicken and the hamburgers. Sounds like a good barbecue. She cautions him to buy enough food for everyone, and she gives you $40 to spend. How nice. At the store, the hamburgers cost $2 per pound, and the chicken costs $3 per pound. Write an equation to model the different amounts of hamburger chicken you can buy. How many rates do we have? 1 or 2?
Well, since when does chicken cost more than hamburger?
He knows all.
The hamburger was probably on sale. You're right, though. Beef usually is more expensive. Maybe it was on sale. Maybe he had a coupon.
I have my food.
Alright, how many rates do we have? 1 or
I
2?
do not.
How many rates?
Great value.
Guys, how many rates do we have? 1 or 2? 2. We have chicken, and we have hamburguesa. Is that right? Hamburguesa y pollo? Alright,
And chicken.
do you guys want to use X and Y? Or H and C? X and Y? Okay. So she told us hamburgers cost $2 per pound, so let's make hamburgers X.
Long and hard. Stop.
Again, we have per. So that means we have to multiply, right? And chicken, let's make that Y. Costs $3 per pound, so we have to multiply again. So 2 times X, 2 times our hamburgers, plus 3 times Y, our chicken. And how much total money does he have to spend? Good. Is that 14? No. That's
What
4. Okay, so we have our equation, 2x plus 3y equals 40. Alright, so how much hamburger can Trey buy if he buys 8 pounds of chicken? So what information did they give us?
Per pound.
Yeah. 8 pounds.
8 pounds what?
Chicken.
Chicken. And chicken is what variable? Chicken is y. So they gave us y is 8. So let's put this into our equation. 2x plus 3 times 8
We could buy 8 pounds of hamburgers.
equals 40. So 8 pounds of chicken, put that in for our very
Last name.
Wait, no, no.
Again, it's good to off to the side state what we have. X is the number of pounds of hamburger, and Y is the number of pounds of chicken.
No worry about the name.
Okay, so let's solve.
People.
3 times 8, you want?
Times 8.
3 times 8. And we subtract our 24 over, and Q1, what do we get?
Say 45.
What's 40 minus 24?
16.
Guess right.
Good job.
Divide by 2, and what do we get, Q1?
8.
Q1, what do we get?
8.
And 8 what?
8 pounds.
8 pounds of hamburger.
Yeah. Sure. 8 hamburgers.
Oh, I think you're.
8 pounds. That's some nice meat. What is that face for?
Is that how you spell it?
No.
No!
Hamburguesa?
Oh, number. Why are you speaking Spanish now?
I heard it when I know it.
And you speak Spanish in that.
Is that how you spell it?
Speak that.
Or is there another U word?
2 ways to fit class.
Is it G-U? Is that correct? Yes! I do remember stuff from high school. Alright, 8 pounds of hamburger. Okay. I want you to now do number 6. I want you to try number 6.
But we had like 1 minute. No, 3
You
minutes.
have 3 minutes. Alright, number 6. So you just did this on your papers. Let's see if you got the right answer. It says, of course, once you get home from the store, your dad realizes that there are no tomatoes and no carrots for the salad. So your dad sends you back to the store with $10. The tomatoes are $2 per pound and the carrots are $1.25 per pound. Write an equation to model the situation. Alright, so we have a total of $10 to spend. And we see we have 2 rates going on. We have tomatoes, which are $2 per pound. We're going to have to multiply again. And we have carrots, which are $1.25 per pound. Alright, let's go and use X and Y. So tomatoes, let's make X. And carrots, let's make Y. Alright, tomatoes, $2 per pound. So $2 times X. Plus how much we spend on carrots, which is $1.25. Times Y, the number of carrots, and we have a total of $10 to spend. Okay, so letter A. How many pounds of carrots can you buy if you purchase 2.5 pounds of tomatoes? Right, tomatoes are X, carrots are Y. Again, we should probably define that over here. X is number of pounds for tomatoes. And Y is the number of pounds for carrots. Okay. So how many pounds of carrots? So they're asking us, what is Y? If you purchase 2.5 pounds of tomatoes, so they gave us tomatoes, we have 2.5, so X is 2.5. In our equation, 2 times X, which is 2.5, plus 1.25 times Y equals 10. Alright, so simplifying from here, 2 times 2.5 is 5, plus 1.25, Y equals 10. Subtract our 5 over, we get 1.25, Y equals 5, and then divide by 1.25. If we do that, we get Y equals 4 is what I meant to put there. Y equals 4. Alright, again in your calculator, do 5 divided by 1.25. Okay, so 4 what? What does Y represent? Y represents the number of pounds of carrots. So 4, actually we'll just write it down here, 4 pounds of carrots. Alright, so if you get 2.5 pounds of tomatoes, you have enough money left to buy 4 pounds of carrots. Okay, next problem. Alright, finally, Kate's older sister Tori is moving out and getting an apartment, which means that Kate now has a room all to herself. When Tori rents a moving truck, she discovers she needs a $75 deposit plus $40 an hour to cover the cost of the truck. Write an equation to model the cost of the truck, y, in terms of the hours it's rented, x. Alright, so $75 deposit. That's our initial amount. We only pay that one time. Plus $40 an hour. That's like the same thing saying $40 per hour or $40 for each hour. So we know we're going to have to multiply there. Right? And they say the cost of the truck, y, so the total cost in terms of the hours it's rented, x. So hours is x. Alright, so again, we have that initial amount of $75, so we pay $75 one time. And then for every hour, we pay $40. So 40 times x, the number of hours. And let's write this in our proper standard form. Or sorry, not standard, slope-intercept, where our 40x comes first. That's our equation. Alright, if it takes 8 hours to move Tori, is $400 enough? So the total cost being $400, is that going to be enough? Alright, so our equation is y equals 40 times x plus 75. And they told us it takes 8 hours. Hours is x, so we take 8 and put that in for x. So we take 8, put that in for x. Alright, so 40 times 8 plus 75. And 40 times 8 gives us 320. 75. Means for 8 hours, it's going to cost us $395. So is $400 enough to move Tori? Well, if it only costs $395, then $400 is indeed enough. So yes, $400 is enough money. Okay. And then finally, our last one. Jen babysits and charges a fee of $20, with an additional $3 per hour. Anna also babysits, but she charges $6 per hour. Who makes more money if they both babysit for 5 hours? Who makes more for 8 hours? So we have a lot happening. First of all, we've got Jen. Jen babysits and charges a fee of $20 with an additional $3 per hour. Okay? So Jen's total amount is an initial $20, one-time fee of $20, and then for every hour it's $3 per hour. So 3 times x. Let's make hours x. And let's again rewrite this in proper standard form. So 3 times every hour plus $20. Alright, then we have Anna over here. Alright, Anna babysits, but she just charges $6 per hour. No initial amount. So her initial amount is 0, but then just $6 per hour. So we have 6. Again, hours is x. So 6 times x. No initial amount. Okay, so the question asks, who makes more if they both babysit for 5 hours? Okay, so we have our equations. Now let's take a look at 5 hours. Well, for Jen, she would make 3 times 5 plus 20. And 3 times 5 is 15, plus 20 would be 35 hours. So for 5 hours, Jen makes $35. For Anna for 5 hours, we have 6 times 5 is again x is 5, the number of hours. And 6 times 5 is 30. So for 5 hours, Anna only makes $30. Alright, so who makes more if they both babysit for 5 hours? Well, for 5 hours, Jen makes more. Jen makes more for 5 hours. Okay. Then it asks who makes more for 8 hours. Alright, so for 8 hours, let's see how much Jen makes. Again, 8 hours would be 8 for x, because x represents hours. 3 times 8 is 24, plus 20 gives us 44. So for 8 hours, Jen makes $44. Let's see what Anna makes. Alright, so again, 8 goes in for X. So 6 times 8. 6 times 8 is 48. So Anna makes $48 for 8 hours. So who makes more for 8 hours? Well, Anna makes more for 8 hours. Anna makes more for 8 hours. And for these, make sure you're actually showing all your work to support this here. So again, remember if we have one rate, then that's going to be slope-intercept form. And if we have two rates, that's going to be standard form. Set up your equation and take a look what they're asking and use that information to solve. All right, so your homework is going to be finishing these notes. Depending on which class period you're in, you should be finishing this worksheet that we just went over, worksheet 13. And then we gave you your review packet so you can start working on that. So we want you to do your odds on the review packet, at least the odds. So numbers 1, 3, 5, 7, so on and so forth. And this is on number 14 of your review packet. So this is, your review packet, which is number 14. Next class will be review, so we want you to come to class prepared with questions over what you have done. We'll do a review activity, and you'll do the rest for homework. So if you want to go and do all of it, you can, but we want you to at least do some of it now to get an idea of what you still need help with.